Hello. Hi, Aaron.
Hey,
Hey, Tony. Hi, Win.
uh,
How are things out where you are, Aaron?
Weird and yellow colored.
Yellow. Well, that's better than us. We're weird and red looking.
No.
We look like we're on Mars.
Yeah. It's
Getting
definitely...
yellow now. It's kind of fading. The red until just an hour ago was the predominant color.
Yeah, it's definitely got that Martian quality. I see your point. It's weird out there. And it's weird. I guess I don't know much about air quality indexes and how they're measured, but the air quality index out here actually isn't that bad.
Yeah.
But
that's because there's an inversion layer that's keeping the smoke at high altitudes. So the smoke is not local.
Oh, okay.
This is coming from the north, and so
right.
It's transported vast distances, and it's really accumulating up there in the upper atmosphere, but it's not actually hugging the ground as it would if it were produced locally.
And that also explains, because what we are getting is a fair bit of ash and even like soot granules, like measurable, visible chunks of stuff falling on, like getting your eyes. And
yeah, it's a very strange phenomenon. I mean, it looks just terrible, but it doesn't smell. I mean, I don't really smell smoke.
No. Yeah, when you go out here, you don't really smell it. But like I said, you stand outside for a few minutes, you'll get like ash particles in your eyes.
Yeah.
Yeah, weird stuff.
Yeah, someone was suggesting that we hold rehearsal outside, band rehearsal, and it was like,
yeah.
So don't want to.
Not going to be pleasant.
No.
hello, everybody.
Hello. Hi, Ben.
Hey, Ben. Thanks for coming.
Yeah, thanks for having me.
Hello, this is Hannah.
So you're braving out the outdoors, Ben.
Yeah, that's right. I'm lucky that I live near a place with public Wi-Fi, so yeah, it's been good for remote work. Yeah.
And outdoors, which is nice.
And outdoors, yeah, exactly. Yeah, really nice. Are a lot of people on the West Coast right now? How's the smoke treating you? How is it? Is everything okay? People staying healthy?
I think people are staying healthy enough. That we have a very strange and unprecedented phenomenon here where the smoke is being transported to the Bay Area where I live along the high altitude air currents, and so it's we woke up today to red skies, profoundly red, like deep dark red, and it stayed that way until about an hour ago, and now it's yellow skies. But it was we've never seen anything like it. It was like the closest experience is the eclipse, like seeing an eclipse where it's kind of pulsar red for a period of time, and it was dark. It was really dark. Like if I had to guess what time it was, I would have guessed 10 o'clock at night. And it was
wow. Okay.
like 7.
Yeah, same deal in Santa Cruz. We have a definite apocalyptic vibe happening for the last week or so. But we're just very happy the town is still here. So no complaints.
Man. Yeah, see, Gary's dealing with a totally different level of apocalyptic experience.
Yeah, wow.
Fires in his backyard.
Right in your backyard, yeah. Yeah. Wow.
And then
well, glad to hear that everybody otherwise things are not, your backyards maybe are safe for the time being. Yeah. Best wishes to everybody.
Yeah, thank you. Shelly, how are you down there in Southern California? Making it okay?
Yeah, the air quality is pretty crappy right now, and my car had quite a bit of ash on it when I got up this morning. So, and the sun looked pretty weird this morning it was kind of an orangish haze. So, but I've seen some of those pictures up in the Bay Area. Those were pretty odd looking for sure. Very orange.
Yeah,
Yeah, very orange.
it's Martian. That's about the closest I can. Yeah. It's pretty
How about in Riverside there, Win?
Honestly, it looks really nice out. There's like blue skies and stuff, and there's a breeze rolling in. I don't know what's going on. It's hasn't been like this for a whole month, but like it's pretty nice.
Yeah, it was pretty smoky yesterday out here.
Yeah. Today is just an anomaly.
This was the view
Whoa.
this morning.
Yeah, whoa.
Wow.
Wow,
Pretty crazy.
that is funky.
That
That's
is crazy.
insane. Oh my gosh.
Wow.
Yeah, the light all day. The light's kind of diffuse and yellow here. It feels like being in a episode of CSI Miami all day long. You know, yellow light constantly streaming in the windows.
Yeah, it's crazy. All right. Well, I'm trying to turn off my screen share, but I can't. I'll get there. So Win, are you going to lead us through the agenda as usual?
That sounds good. Yeah. So thanks everyone for coming today. We are privileged to have Ben from the Benioff Ocean Institute joining us to give us a presentation about his work developing trash AI technologies with 9 other groups around the world. This is the guy that I've been talking to you all about, the project that we just need to hear about to get our AI inspiration set on the right track. So thanks a lot, Ben, for coming. And I guess I did tell you a little bit about this group initially, but I can give you a little bit more background. We're part of the Water Quality Monitoring Council. We're a part of a task force with them to develop trash methodologies, and part of that is the data management. And so that's the group that's in this room. We're the data people, the trash data people in that group, and we've been working on the trash taxonomy together that I've shared with you. And right now we're at a turning point where we're trying to figure out what our next project is, and we think it's going to be something with AI. Several of us in this room are AI practitioners, and we also have Dr. Novotny joining us today. Hi. I was just introducing Ben, our speaker today, and also thank you, Dr. Novotny, for I might be mispronouncing your name, and I apologize.
No, you got it. It's perfect.
I got it? All right.
Yep.
Yeah, thank you so much for joining us. Really appreciate you being a part of this group. And
Very interested in what's going on with this. Yeah.
Yeah,
so,
we look forward to hearing from Tom Novotny next time. We're planning to agendize his project, which is
that's right.
It's about doing some of the environmental economics behind the impact of tobacco product waste.
Yeah, definitely looking forward to that. All right, so that was my long-winded intro to all the folks, introducing everybody. Today on our agenda, let's go around and each person could introduce himself real briefly. If you have any updates in the trash world, go ahead and share them with the group. And then if you have any additions that you'd like to add to the agenda, I'll share my screen, or maybe Tony, you could put the agenda up just so people could.
Yeah, can you do it? Can you share your screen?
Yeah,
I'm kind of partially locked up here.
Let me see if I try to share my screen, is it able to boot you off?
Yeah.
Let's see, I just tried to click it, but it says you cannot start screen share while other participant is sharing.
let me see what I can do. Sorry, keep tap dancing. I'll be right.
Okay. Anyway, so yeah, I'm Win. I'm a co-lead of this work group with Tony Hale, and we are trash data. I call myself a trash data junkie. All day I eat, sleep, breathe trash data. Trash updates. Let's see. Trying to think of what's big right now. Oh, there was a paper that came out with Tim Van Emmerich and Colin. I can't remember his name, but a paper on river trash AI, developing technologies for detecting trash in rivers using cameras mounted on bridges. That was pretty cool. So I'll pass. I'll popcorn over to Aaron.
Hey, my name is Aaron Heyman. I work for the Sacramento San Joaquin Delta Conservancy, which is a small state agency. And one of the things that I'm involved with in the Delta is trash cleanups and getting started with more trash monitoring, in particular citizen science trash monitoring. And one of my other forms of involvement with this sort of larger group is I'm the co-chair of the Citizen Science Subcommittee. So one of the sort of sister subcommittees to this one. So yeah, trying to sort of help out here, lend a citizen science-y perspective, and also glean whatever I can from you guys to bring back to the Citizen Science Subcommittee itself.
Do you want to pick somebody?
That's me.
Do you want to pick the next person, Aaron?
Yeah, Shelley, go for it.
Hi, I'm Shelley Moore. I'm the co-chair of the Trash Monitoring Work Group. And as far as updates, we're hoping to have our next meeting for the overall Trash Monitoring Work Group, probably early to mid-October at this point. And that's the only update I have, other than I'm being goofy today. So I had taken my hat off, but I'm wearing my birthday cap today because today is my birthday. So.
Happy birthday!
Happy birthday!
Happy birthday,
Happy
Shelley.
birthday.
How about Russ?
Yeah, sure thing. Happy birthday. So for those of you who don't know me, I'm Ross. I'm the current California State Sea Grant Fellow, and I'm working with the State Water Resources Control Board, more specifically the Office of Information Management and Analysis. And so I've been helping out on a few of these trash work group subcommittees, both this one and the Citizen Science Subcommittee as well too. As far as updates go, we are making some progress towards having something ready for the fall trash event with the water board. Still nothing too concrete, but we have a couple different directions we're thinking of going, and we're trying to narrow that down. Obviously, well, we're shooting for early November, and that is coming up. So obviously we'll have to put something out sooner rather than later. And I think I'll be meeting with Greg and Nick next week or two to really start getting something onto paper, and then hopefully by the next entire trash work group meeting we'll have something more concrete that we can put out, at least just to get it on your radar and your calendars, and then we can kind of fine-tune it from there, because there's a couple ways we could go with it, a couple good ideas, a couple ideas that I think we don't have enough time for. Obviously things have been thrown for a bit of a loop this year, but we're making progress. So yeah, that's about it for me. So how about Jarma up next?
Good afternoon. My name is Jarma Bennett, and I also work in the Office of Information Management and Analysis at the Water Board. And I'm oversee the CDN database, which we may be able to use to store trash data consistently, but we're still checking that out. And I'll move on to Ben.
Hey everybody, I'm not in the trash monitoring work group, but I'm excited to be here. Thank you for having me. My name is Ben Gyron. I'm an AI research associate at the Benioff Ocean Initiative, which is a group that's housed within UC Santa Barbara, but we're a little bit of a hybrid group. We're not a traditional lab or research group. We work on basically just partnering with organizations to develop solutions to a host of marine conservation and ocean health issues. So we're a project-based group, and we started a thing called the Clean Currents Coalition, which I'll talk about. But yeah, I focus on projects that involve machine learning, and I'll say more in my presentation, I guess, and pass it off to, let's see. Oh, Tech SFEI. Your name.
Let me change my name. But yeah, so I'm Tony Hale, and I'm with SFEI, the San Francisco Estuary Institute, co-lead of this work group, of this subcommittee. And I work alongside Shelley on a number of different trash-related things. Just heard today from
We lost you.
I can't hear you, Tony.
now? Can you hear me now?
Oh, yep.
Okay, cool. What I was saying is that I just heard this morning from Oracle, who has given us some supplemental funding to a Department of Public Health project that Shelley and I are working on, that they want to feature us as a case study in the use of machine learning and tobacco product waste. So that's pretty exciting. We're developing an algorithm that can detect cigarette butts specifically in certain environments, or what they would call scenes, so that we can help automate that process of capturing, counting cigarette butts, which is a very arduous and onerous process. So making it automated is a step forward. So that's something that we'll be continuing to develop. And so Ben, I'm really looking to comparing notes with you. And I'm going to pass on the mic to, I'm going to drop the mic right into Gary's hands. Gary, can you put your hand out? There you go.
Got it.
Okay.
Thank you, Tony. Hey everybody, it's Gary Conley. I'm with Second Nature Software. We build systems to help cities deal with stormwater problems, water quality compliance, and trash is one of those things that cities have to deal with. So generally, we try to build these systems such that they provide better information for making decisions, and that often means quantifying the uncertainty in those estimates or measurements, along with the statistical power for them to detect changes over time, just so cities have a richer data set to draw from, to be able to know whether things are changing, which direction they're going, and where they might want to focus their resources. We're trying to make this whole process of turning the data that we collect into useful information more efficient, and on the trash front, we're exploring ways that we can use machine learning and image capture to do that, for cities to have a better impression of what's the trash status of their cities, where are problems most severe. All data collection is sampling, and so if we can sample more efficiently, we can know more about the system, and it just feels like a problem really built for machine learning. So I'm really excited to hear for what you have to say today, Ben, sort of like this problem in a little bit different realm. Right now, we're working primarily on measuring volumes of trash that you walk along and collect on the street, and comparing that to outputs from machine learning algorithms that work on imagery. So that hopefully we'll have some results to know how useful that's going to be in the near future. In terms of announcements, we have a panel coming up at the CASCA meeting next week that is all about trash, if folks are interested. And this panel is going to, this is Stephanie Castle, Stephanie's last name, is at Fusco Engineering, is organizing the panel. She's done a great job getting us all in line. And the idea is it's going to trash the evolution of how we assess trash problems in cities and where we're going in the future to be able to synthesize all that data and make some better decisions going forward. So should be a good one.
Could you drop some information, like a link to that in the
I
chat?
will do,
I'll
yeah.
add to the agenda. Thank
Yeah,
you.
I'll do that, Win. Oh, who have we not heard from?
I think that's everyone.
That's
Oh,
it.
Tom.
No, I think that's it.
Tom.
I can give a little quick update too. I'm Tom Novotny. I'm a professor emeritus at the School of Public Health at SDSU. And I have been working on this butt issue for a decade or more. And recently, the state health department has agreed to fund a project that I'm going to lead to estimate the economic burden of tobacco product waste in the environment, both cigarettes and e-cigarettes, and to draw on lots of different sources, which sounds very interesting in terms of the kind of data collection that would be done here, because you can get a sort of a quantity of the cigarette butt waste in various environments, various kind of scenarios, then that can be translated into a costing that we hope we can do. We're going to be looking at a lot of other costing research for other kinds of environmental contaminants or trash or waste, and looking to see what we can learn from that. That's going to be one of the first tests, but also to really look at both direct and indirect costs, meaning, like cleanup, but also indirect things like ecosystem services losses and issues that are less sort of tangible to people, but yet still can be costed. So we've got that. And then the other thing that just happened in a couple of weeks ago is that the state put out an RFA, that's the State Tobacco Control Program, put out an RFA to do a white paper on tobacco product waste, meaning to try to just collect everything information-wise, kind of like a Surgeon General's report on smoking, in one place that can then be, used as a baseline for the science and identify what the gaps are. So I'm applying for that grant because seems like I have a lot of different places where I'll be able to bring in information. So if we get that, that will be a one-year project starting in March that would then end up with essentially a large document that would be a collection of all of the science related to tobacco product waste that we can find. Science as well as gray literature as well. So I'm going to keep busy in my retirement.
That's great, Tom. Margaret just joined us, Margaret Macaulay of USCPA. Margaret, what we're doing is we're just going around and sharing any updates related to trash data.
Yeah, that'll work. Sorry, I've got a little remote learning.
Sure. So why don't we go ahead and move on? We can circle back to Margaret when she returns.
Sounds great. Yeah. Well, the only other thing that I had on the agenda besides Ben was just a quick update on the charter. I've gone through and done another pass on the charter. I've sent it off to a couple of folks at the homeless encampment committee to ask for some input directly related to their project on it. And then I think the next step on that will be by hopefully the next meeting. We will send it over to the work group at large.
Sounds great.
So with no further ado, I would like to welcome Ben to take the reins. We can pass over the controls so that you can share your screen and And yes.
Okay.
Thank you.
Thanks, Win. Thanks, everybody. Let's see here. Let me try to present this. Okay, is that in presenter mode? Does that look good?
Looks
You can
good.
see it? Okay. Thanks, everybody. You know, before, basically what I'm going to do here in this presentation is I'll keep things kind of short and just give sort of an overview about this whole body of work, which, you know, we sort of call computer vision for clean currents. And then we can go back and dig more into detail about questions or things you're really interested in and what's relevant to you know, to your individual lines of work and your work as a group. Let me preface this by just saying that, you know, I am no trash expert and I won't pretend to be. You all are the trash experts. This is not my domain knowledge. You know, my background is in artificial intelligence, as in computer science. You know, this body of work really just started in the last 4 months or so. And so definitely a new landscape for me. And so, yeah. The other thing I would just mention is that, you know, what I'm going to share with you all today is sort of a vision for how we are thinking about applying computer vision to the river plastic space within our coalition of organizations. And the bulk of this work hasn't really started. And so, you know, I'll share where we're at and where we're going. And there's certainly a lot of open questions here and a lot of learning to do. So excited to get your input and learn together as well. Okay, along the way, maybe stop if you have any questions. Feel free to interrupt me. Okay, so first I'll talk about what is the Clean Currents Coalition. And then I'll talk briefly about some existing work in the sort of computer vision plus river plastic space. And I'll share with you our vision for this body of work, computer vision for clean currents. Talk about what we've done so far and where we're going. Okay, so first of all, what is the Clean Currents Coalition? The Clean Currents Coalition is a collaborative network of 9 teams combating the flow of plastic waste from rivers to the ocean at river sites around the world. And the CCC is funded by my organization, the Benioff Ocean Initiative, as well as the Coca-Cola Foundation. And the goal here is really to support these 9 teams as they deploy river plastic capture devices at these 9 different river sites around the world. Each team has their own plans of engaging the local community, and they each have different device designs. Some are new, some are existing models. And each of them have their own plans for engaging the community, working with local governments, sharing the data out, repurposing the waste, recycling the waste, disposing of the waste. And some teams do have plans to capture images and do computer vision work. And so this body of work, computer vision for clean currents, really started with these teams coming to us and saying, hey, we have these ideas about gathering images and trying to build artificial intelligence models that can help us do autonomous data collection. Let me pop, let's see. Can I share in the, Wynn, do you want to share the slide deck in the chat? It seems I can't do that right now that I'm,
I can do that.
Oh, actually I can. Sorry, wait, hold on a sec. Got it, okay. Just did it. Yeah, so feel free to follow along on the slide deck. You can also refer back to the slide deck later and click on these links. But we have a website, the CCC website, and we have these 9 teams around the world. They're sort of shown below here. So we've got Renew Oceans, which, as you know, Wynn is working closely with at the Yangtze River in India. We have a group in Kenya, another group in Indonesia, Jamaica, Mexico, Thailand, Panama, Ecuador, and Vietnam. And each have maybe multiple each has sort of like a core team that is, each of these river sites have, a team that's working to basically deploy a capture device and execute a full community engagement plan and test their device in these waters. This is work that we funded, and this is what our coalition composes of. And we keep folks, exchanging open dialogue over Slack. We have regular calls with each other. And the goal here is really to share resources, share knowledge, and share data. Okay, any questions about the Clean Currents Coalition?
Yeah, I had one quick question. You've not been approached by the tobacco industry, have you, on sponsorship?
Interesting. I wouldn't know. I wouldn't know. I can't say if we have or haven't. I can ask my colleagues if you're interested.
Yeah, I would be, and I think it's important just to resist that at all costs, because they've been funding Keep America Beautiful and Ocean and a lot of other groups, and it doesn't lead to anything positive. So anyway,
yeah. If I'm going to be honest, it doesn't look also great to have Coca-Cola on this either. They have been generous to fund this work, and they've been good partners in this work, and they've been mostly not engaged in this work. But that doesn't look great either, and we're sort of aware of the problematic outlook of that for sure.
Yeah.
Ben, while we're stopped, just another quick question about the Tijuana project. You mentioned that you have a site down there. I wonder, I know that there's a group that is doing surveys of the Tijuana River using drones and computer vision to estimate the amount of trash in that river, in that plastic river. Are you at all aware of Four Walls and the UCI-based project that's going on down there?
Yeah, so Four Walls is a partner with our team that's working out of the Tijuana River.
Oh, great.
So, yeah, we've been in touch, and they were a part of our initial workshop, but our communications have been sort of, they've been taking a little bit of their own independent streams. I think they've been, I can't really say for sure exactly where they're at in terms of their progress.
Mm-hmm. Yeah, we had some early contact with them, and then have just kind of fallen by the wayside. So I would like to remain in touch and find out where they are.
They've just gotten a big tranche of money, I think, too. I can't remember the source, but I saw this advertised on, where was it? Jen Campbell's website, maybe, I don't know. But it was, yeah, it seems like there's been some big investment just recently.
Oh, okay. Well, that's good. I'll continue to probe.
Okay, so I'll touch on the existing work in this sort of computer vision and river plastic space, and some of this might be already familiar for you. And this is definitely not all encompassing, but let's see here. Sorry, I keep dragging you. I'm struggling with my Zoom. Okay. So there was a limited amount of publicly available ocean/river plastic image data sets. There's plenty of data sets, as you know, about river plastics out there, but little to none consisting of imagery. And there are examples of underwater plastic imagery data sets. This struck me as interesting when I first started in this work. I saw that, if someone wants to do computer vision work on river plastics specifically, there's not a lot of options out there for you. Some existing ocean river plastic AI modeling efforts, of course, with a lean towards river plastics, because that's what we're really focused on, not so much the the ocean environment. Most notably, Australia's CSIRO is working with Microsoft on developing computer vision for analyzing video feeds in rivers, storm drains. They have a data set so far of about 3,200 labeled images. Actually, Wynn and I were just on a call with Ariana Olivieri from CSIRO today. And so dialogues have been open there. A Japan-based group called Purika is training their own models for detecting waste along Japanese riverbanks from aerial drone imagery. And so something notable there is that they're using drones specifically, and they're primarily focused on the river blanks and less actually on the on floating plastics. You've probably heard of this one. Yeah, the UK based Plastic Tide, which is has had its fair share of trials and disappointments. They collected drone imagery of shoreline plastic and trained models that maxed out at only about 30% accuracy. Here's a paper on training an object detection model with about 80% accuracy. This was pretty interesting. This author made a data set of plastic floating in a water tank. So tried to mimic an environmental experience in a water tank. Fulton and their co-authors evaluated a series of computer vision architectures applied to the task of identifying plastic waste in underwater imagery, though. So again, not floating rivers. You know, there's this open source kind of unknown model called Antiplasti just out there. Okay. For within our Clean Currents Coalition, definitely the most sort of advanced team on this front is the Ocean Cleanup. So far they've labeled about 1,200 of their own images, and they recently published some preliminary computer vision results, which is really great to see. So you can read their paper there. It's linked on this slide. They've collaborated with Microsoft on building some of their initial modeling architecture. And they have cameras deployed in both Jakarta and most recently also the Dominican Republic. And what they've been doing is they've been mounting cameras on bridges and pointing them down at a 90-degree angle. They have their own set of image standards, and they annotated these images with the help of citizen science volunteers. But then, of course, you know, you often have to go back and relabel everything. As the citizen science folks in the room might understand, sometimes you get sort of mediocre data. So yeah, they had to do a lot of reworking of their annotations, but they did get a small data set to start with. About, I think there's over 12,000 total annotations in their data set. And I think I would strongly suggest reading their paper. The paper explains what they've seen so far, and their initial results are promising. And so that's been exciting for us. And of course, they're close collaborators, and they're part of the CCC. You know, when before I really got involved in this work, I was reading the proposals of these different teams and seeing that people had plans to collect their imagery data and work on their own individual modeling efforts. And I thought, like maybe actually this would be a really good point of collaboration. Maybe there's a way to actually combine this data to make it a really valuable data set and try to combine our efforts here. What we're really looking at is, you know, with the power of the Clean Currents Coalition, you know, our teams, we can really leverage the diversity and scale that we have to create a large data set of annotated images of floating river plastics. And I think this would be a valuable contribution to this emerging field of applied computer vision. So yeah, I think we do have an opportunity to do novel experimentation to test the generalization of these models and model infrastructure to novel river sites, and to work with collaborators outside of our coalition to share resources and data. Okay, I want to outline our vision for for this body of work, computer vision for clean currents. At the high level, the sort of way we're thinking of going about this is, having a centralized cloud storage space where coalition teams can upload images to on a regular basis. And then we have a centralized organization of annotation work supported by the Benioff Ocean Initiative to create a data set that is diverse in image source. So it's sourced from many different river sites, but still consistent in image standards. So there's not a whole massive range of image types, images on conveyor belts, images on banks, images floating at different levels. We want to be relatively consistent in our image type, and also consistent in our annotation form. So we label X as a plastic bottle, and it's always labeled that way. We label X object as trash, and it always shows up as that in our data set. We create this data set and share the data set publicly online, and we leverage that data set to further our own computer vision development work with internal and external partners, in the eventual hopes of trying to build a cloud-based prediction pipeline that all of our teams can be using. So our driving research questions here is really, asking, can we achieve better accuracy and efficiency with AI than with manual sampling? Can we build a generalizable model that requires limited to no additional data collection and annotation work? So, if one of our teams or any organization for that matter, or even outside the coalition, expands to novel river site that the model hasn't been trained on, hasn't learned how to detect trash at that river site, how well does our model perform? Do we need to go back and collect a bunch more new data and label a bunch of new data? Or do we only need to do that a little bit? Or do we not need to do that at all? So how much extra effort does it take to expand our model to a new river site? Can we, as a coalition, build a cloud-based AI-enabled monitoring system that is easily shareable? So can we build a prediction pipeline that is run in the cloud continuously on new images that are being streamed in near real time, maybe not even near real time, but can we make this infrastructure shareable? And lastly, can we extract insights beyond trash/no trash? That would require us to label images at a level more granular than trash/no trash. And so far, pretty much all the organizations I mentioned in the existing work section, they are just focused on trash/no trash, because that is, as you probably all are aware of, that's hard enough. But can we extrapolate more interesting information about flow rate? Are there specific trash types that we could pick up in images given a certain resolution? Part of our work is trying to identify image standards that we're going to adopt as a coalition. And as you're probably aware, computer vision model is challenged by poor resolution, occlusion of objects, having a wide diversity of environment/settings. So we need to be mindful of these things. We have to think about things like camera placement. Are we placing at points of clutter or points of trash flow? Our angle, our image size and resolution, those things matter, and we want them to be relatively consistent. Lastly, I mentioned that we're really looking at trash/no trash annotation because that's hard enough, and because that's what pretty much everybody is sort of focused on right now. But some people are annotating at a more granular level, and it's to be determined how computer vision models could perform at a more granular level. And so these are conversations we're still having about, how granular do we want our annotations to be? what is the optimal point down this tree? And, attaching also different additional image attributes. So something you have to think about when you're annotating a bunch of images is that you might want to label certain odd scenarios, so you can selectively get train either cancel them from your training data set or specifically train more on those situations where objects are truncated or difficult, sort of ambiguous, or there's occlusion, objects overlapping each other. We perhaps want to be including those in our annotations. Okay, before I briefly cover what we've done so far and where we're going, can I answer any questions about our vision?
I have a question,
Mm-hmm.
or a couple. So yeah, I think one of the things that I think is very challenging is that when people are talking about trash, what I've discovered is that it's only a matter of time before people start to elide the difference between trash and plastic. So they're often really talking about plastic. And so when you're talking about the classes that you might refine the trash to, it seems that you're going to be, as you move forward with this project and as you're engaging with different stakeholders and partners, there'll be more and more pressure to discern plastic from not plastic within the trash, that upper trash category. So, and there are different ways to kind of get to that, but I think that that's likely to be an ongoing discussion if you don't decide to distinguish between different forms of trash, only because plastic is enduring and other things are faster to break down and maybe not cause as much environmental harm. The other, so that's more of a comment. The question I have though is about your operationalized monitoring system, and I think these things are kind of interrelated, because if you are, first of all, I applaud the idea of creating this kind of cloud-based system whereby you would submit images and then derive data. So that's very much kind of something that we've been thinking about as well. And I wondered if you might also consider within the architecture of that system ways to kind of modularize it. So anticipating that as people use it, they will inevitably want different refinements. That is, I want to see only, if I submit images, can I get plastic? If I submit images, can I get tobacco waste? If I submit images, our program is only interested in plastic bags, whatever it might be. And it may be a place you don't want to go because you're just interested in the trash, not trash binary. But if you want to generalize, but also then refine, it seems that having some kind of way to parameterize or modularize that system and go in with the assumption that that's really what's going to happen might be of greatest advantage to you, so that it is most enduring, rather than just kind of a basic proof of concept that really can't go very far. Do you have any comments on that?
Yeah, for sure. Thanks, Tony. I think your idea is great, and it's especially, I think it's something we would definitely consider and probably end up doing if we end up annotating our images at a more specific level than just trash, no trash, or plastic, no plastic. That's something from sort of a computer science standpoint, it wouldn't be too hard to do, to specify that you only want to consider certain classes from your model output. I think that's something that would be totally doable. The thing where it gets tricky is, okay, across these various classes that we have, how well does our model perform on each class? It's going to vary from class to class. It's going to vary from place to place. And so I think it's way too early to say whether we can, even if we annotate all of our images at a more granular level than trash, no trash, I think it's too early to say whether we're going to see good performance across a given set of classes that are more granular, and how generalizable those would be to other rivers. I think that, yeah, but I'm very curious, and the idea is great, and yeah. Thanks for that. Any other questions? Okay, so just briefly what we've done so far. So we formed a working group of about 5 of our teams with as well a few external collaborators. And right now we're setting up on trying to define our image standards for these participating teams to use for their image data collection to ensure that our data is consistent enough such that we can train on the same models and still achieve good performance. 3 of our teams are collecting preliminary images, setting up cameras at the river sites. Some teams are encountering difficulties with COVID, as you can imagine. Getting permits to set things up and be present on the ground is pretty difficult right now. And right now, I'm working to put together a small hack team to run a few data augmentation and generalizability experiments, which build off of the Ocean Cleanups paper and uses their data. So we're going to be doing, as things are sort of floating in parallel, we're going to be just running a few experiments to help build off of their existing work. Yeah, okay, here's just a few teaser image samples. Yeah, from a few of our partners, including WIN's Renew Oceans team down there at our different river sites. We're going to be dealing with a whole host of different river environments here, and obviously, as you can see, these 3 images were taken from different vantage points. The Chemolex image on the left there is a drone sample from a riverbank. The Ocean Cleanup mounts their cameras on bridges, and so that's a bridge mount. And Renew Ocean's team, that camera is mounted on a nearby building, taken from a more distant perspective. And so, yeah, just to give a little bit of a view.
Something I'm wondering about with integrating all of these different types of images into AI is there an AI out there that can accept image metadata, like such as what is the spatial resolution of the image? What is the camera angle of the image? Because if the AI can take that information in and then use it to interpret what's in the image better, maybe that would improve over just like throwing images in to a classifier. I'm not sure though. I don't even know if there is some sort of machine learning strategy for doing that.
Yeah, that's an interesting line of thought. When I think what it makes me think of is more like a data pre-processing step. So what you're getting at here is like, okay, let's say we have a bunch of images at different resolutions or something, and you want to treat them differently. Then you could sort of take the metadata and separate the data sets and feed them through their separate models or something, or you could have a multi-step modeling architecture where you feed all the images through one model and that just detects the presence of objects, for example, and then you get more specific and you can branch them off at another layer into more specific models that do another task.
Okay. So, all right. Yeah, that makes a lot of sense. So it'd be kind of like splitting it off and developing models for those different scenarios. Yeah.
Yeah, exactly.
Thanks.
Yeah. Any other questions? Okay, where we're going. So on the image collection standards front, and this is something that when we've been talking about the last few weeks, is trying to set of requirements for our participating teams to use, such that our data can be shareable and usable. So something we're trying to figure out is how to decide on some set of smallest object requirements. So let's say we want to detect a 10 centimeter by 5 centimeter smallest object, okay? Or we say, the smallest object I want to be able to see at my river is X by X centimeters. And we want to be able to see that object at a resolution of Z. Based on just that requirement, what do all of our other camera collection variables need to be. So we've been talking about building some simple tool for adjusting image capture variables like focal length, distance, etc., according to our smallest object requirement. And we're sort of dealing with the complexity of the situation, which is that these different teams have sort of, some of them already have some solid plans, some are sort of brewing up their own plans, and so we need to figure out how to get folks sort of on board, and recognizing also that for one, the ocean cleanup is already collecting their images, they already have cameras stationed, they might be less willing to adapt, so we might need to lean our coalition closer to them if we want to collaborate. Image collection. So on that front, we want to be deploying upstream and downstream cameras at river sites of each participating CCC team. Some teams are already doing this, and prepare our cloud storage space and start feeding images to that space. On the image annotation front, there's still a lot to do here. We need to be electing our annotation standards, make an execution plan, secure funds from Buoy, and start annotating as images roll in. And then publish that data set open source on Kaggle, even while it's still unfinished. Model development front, we want to be doing some continuous integration of experiments, building with the goal of basically getting to a point where we're building a generalizable baseline model that requires limited to no additional data at novel river sites. And then still stuff to do on the software engineering, cloud infrastructure front to build a cloud-based prediction pipeline that's shareable. To some degree, some of this might already be in existence for use from other teams. So, the Ocean Cleanup has their own that they're building with folks on Microsoft. That might be made shareable. So, still conversations to be had there. That's my last slide. Okay. Yeah. Any questions, thoughts, feedback?
This is really great to see, Ben. I think this is definitely needed, and certainly leveraging these parallel efforts and bringing them together is very admirable and something that needs to happen. So I think that this is really great. Among the things that I would imagine you'll need to work out is that there is some advantage to having parallel efforts using slightly different techniques. I know that you want to set a standard and go for it so that you can kind of make progress as quickly as possible, but there is an advantage to almost the competition and the tests of having certain things held in common, but changing variables to ensure that you are truly following the most efficacious path. So I wonder if you've given some thought to how to establish certain things that you are held in common. So for instance, we are definitely going to be looking with nadir imagery straight down at a creek with this particular thing, but we are going to be using this particular algorithm, but then this other group is going to be using a slightly different algorithm, so that we can judge what is the most effectiveness of these different efforts and then follow the winning horse, if you will, rather than settling too soon on some of these very critical things and then being married to them because you've committed so much to it, right? So I wonder if you've given some thought to that, kind of what are the things that need to be standard and what are the things that can be variable, so that you can give the best test of efficacy to the things that matter. So that's one question, and I just want to mention one other thing. We have some experience doing the annotation, and one thing that we've learned along the way is that it's most critical to have annotation tools that are browser based rather than like based on an application you install. Just that it makes it really easy to share not only the unannotated yet to be annotated data, but then the results
and everything else. And establishing the standards for annotation, I think, are very critical. So that's not where I would say, let's go ahead and add a lot of variability, right? But making that very clear, that's going to add a lot of value, because it seems to me that you started out your presentation talking about the dearth of data in this particular area where you really need it. And so making sure that the data that you are collecting is comparable, making sure that it's all feeding into a larger project, but then maybe applying different tunings and different algorithms to that data set could be, at least for a phase of your project, to be a something that you would like to at least entertain. So I wonder if you'd like to respond to that.
Yeah, I think.
And it could very well be, Ben, I just want to caution that maybe I missed something and you've already declared this, so I apologize if I'm.
Oh, no. No, Tony, your comments are extremely valuable, and I really appreciate them. In fact, when actually, Tony's comment about the variability versus standardization is exactly what Tim Van Embrick was saying this morning. Suggestion this morning was to focus more on this. And this is something that I think we have not done our due diligence to think closely enough about, to what extent we want, especially the data, to be standardized. Because obviously there's an advantage from just a work standpoint to allow everyone to sort of collect the data according to their methods. But from a modeling standpoint, if our goal is to create a sort of prototype of like a baseline generalizable model, it's going to be made much more difficult to do that if we don't standardize to some degree. So drawing this line is tricky, and I think you're totally right that this field is new, and we probably do need a lot more competition, experimentation, and so I think there's more thinking to be done there, and I lean on folks like you, Tony, to provide your input. Thank you so much also for the browser-based annotation suggestion. This is something that we also, we've done one big annotation work, at least within the Beneficiation Initiative so far, and this is something that we encountered too. A non-browser-based, often, things crash, people have difficulty mounting their software, and yeah, there's also that issue. But yeah, your comments are really appreciated.
I recognize we're a couple minutes over time. Time flies when you're having fun. So if anybody needs to go ahead. If anybody has any more questions, maybe we can convince Ben to stick around for a couple more minutes and answer those. But if not, it's all right too.
One final question for Ben, realizing we're over time, but can you, it seems like this is such a critical project, and I love the partnerships that you're forging. How would people get involved if they want to join your either internal or external partnerships?
Mm-hmm. Yeah, so they can definitely reach out to me, to Win, and it's kind of informal. People just hear about other people, and then we set up meetings, and then we eventually, we invite people to join our Slack workspace where we have some conversations. Yeah, does that kind of answer your question, or?
Yes, thank you.
Okay.
I did have one quick question too. This is funded and sponsored really by NGOs and academia, it looks like, and the Coca-Cola Foundation. But have there been any jurisdictions express any interest in your work as yet, or have you had any contact with them? Whether the regulatory agencies or just governments, local, state, etc.
Yeah, so certainly that's happening at the team level. So individual teams are most if not all are working closely with some local government agencies. In fact, there's often permitting processes involved, and they have their own plans to engage local communities. I'm personally not involved in this aspect of the work, engaging with government stakeholders, engaging with local communities. I can connect you with colleagues that are, that can also then connect you with individual teams. There, you can read a little bit about each team on the website as well.
Okay.
But yeah, let me know what information you'd like, and I can connect you.
Great, thanks.
Okay, I'll drop my email in the chat. Is that kind of it might disappear, I guess, but so mark it down if
I'll
you.
copy it into the agenda.
Okay.
Before we hop off. Yeah, thank you so much, Ben. Thanks everyone for coming today, and next month we will hear from Dr. Novotny about his current project. So really looking forward to that. Hope you all have a good rest of your September, and see you in October.
Thank you, Win. Thanks for keeping us on track.
Yeah, thanks, Win.
Thanks, Wayne. Thank you, everybody.
Thanks, Ben.
I know.